Hello everyone. Hi guys. Today continue I continue my challenge of solving one Leetcode task every day. I solved array, hash task, stack task. Today I need to solve two pointers task. So let's find it. Two pointers. 194 tasks, problems, questions. Some of it I solved already. Someone in the past I don't remember it. Is subsequence, linked list. It looks like I solved two pointers tasks more than others. As usual, let's take first of easy ones. Well, remove duplicates from sorted array. Given an integer array nums sorted. Let's scale it a bit. I think this one is okay. Given an integer array nums, sorting it in sorted array in non-decreasing order. Okay. I need to remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. Change the array nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size of nums. Interesting. Custom judge. The judge will test your solution with the following code. It looks like something specific question. I don't know. Sounds like some C++ question. Okay. Judge will test your solution with the following code. Int nums, expected nums, remove duplicate nums, assert k, expected nums length, for int I0, assert nums e. If all assertions pass, then your solution will be accepted. So we even don't need to make some no, we need to mutate nums because it will Okay. I need to change nums array. I see. So I understood the question. I got it clearly. Let's try to find out how I need to solve it. As of given array is sorted in non-decreasing order, then what we can do? We iterate through array. Let's take some example. I iterate through array, and maybe I remember the last I remember the current number to somewhere. Then if it's not, if this number is if current number, let's look at this, if this 0 is not yes, if this 1 is not the same with previous, then we put 1 to the last watched, last seen number and move on. If we compare this one with the previous, we see that it is the same with previous. Then what can we do with it? We see 0, 0. I need to remove this 0, 0. Yes, let's abstract from indices, etc. Let's consider in casual way. I don't know how to say it another. We see 0, we see repeated 0. What should we do? We need to get this kind of answer. So 0 should be removed, or it can be moved to the end of array. It doesn't matter. And we can splice the array, and or we can swap the 0 with the last. No, I can't swap the 0 with the last item. Then the last item will break the order of in the array. So I need to just remember its position and move until the until I find non-repeating number and put it here, and then go to the next index and search for next non-repeating number, put it here, and then do it again and again until I get to the end until I reach to the end of the list. Why it's named it? Why it is two pointers? Two pointers. I need to find out what is two pointers, because I don't. What is two pointers? Technique, effective technique that is typically used for searching pairs in sorted array. Given a sorted array A, having identified if there is any pair of elements such as their sum is equal to X. Illustration. The algorithm basically uses the fact that the input array is sorted. We start the sum of extreme values and conditionally move both pointers. We move left pointer. I need to have two pointers. Okay, and use the fact that array is sorted. Okay, then I start to sum extreme values and conditionally move both pointers. We move left pointer. So here we'll be proposing a two-pointer algorithm. By starting off with the naive approach only in order to showcase the execution of operations going on in both methods, and secondary to justify how two-pointer algorithm optimizes code via time complexities across all dynamic programming languages such as C++, Java, Python, and even JavaScript. Okay. Naive solution. So I have nested loops. If I equals j, it just guard, pair exists, return 1. If as the array is sorted and our sum is more than x, then we understand that we pass the searching numbers. Then we need to break inner loop and move to the new iteration. Okay. We take two parts. I see. I need to use this technique. So I need to use the fact that the array is sorted. How can I use it? I remember the first item and the second item. If let's start with this one, the first index, the second index. If items is the same, we iterate until the inner loop, until it's will be not the same. When we see not the same, we put this item to the we the I will be 0, 1, 2. The J will be 3, 4, 5, and we find not the same items. What we should do? We should put this 2 to the I plus 1 place, then assign I to J, and start over the inner loop with I plus 1 again. I like this. Let's try it. For let I equals 0, I less than nums when I plus equals 1, or let J equals I plus 1, J less than nums length J increases. If let's start with guard is I equals J, then continue. If and or nums I equals nums J, then continue to. If not, then what we do? We make nums I plus 1 equals nums J, I equals J, and I think that's it. And then we need to break inner loop to start it over. That's it. Oh no, wrong answer. Output 1, 2, 2, expected 1, 2. How can I got the wrong, but guys, in the description it's written that the remaining elements of nums are not important, as well as the size of nums, but you have, oh my god, tests that check the remaining elements. Okay, I need to find out how to cut the nums length when I break it. The last time I make this assignment will be the correct length of array with unique elements. Var k equals 0, and we k equals I equals j, and nums length equals k. Let's try it. K plus 1, sorry. My algorithm doesn't work well. I skipped zeros, but I not sorted. Okay, the K is works. I check only the first one. I need to repeat watching again. If exists, if the array sorted, we break and don't iterate. We break the loop. I break the loop if I need to break it. No. When I need to I break it, but I don't understand. Well, let's try. I equals j. Maybe I need to make this j plus 1. I don't know. Let's try some hack. No, it doesn't work. The hardest one, I need to find the bug. Why it doesn't work? Well, we start with first pointer. First pointer, look at first item. Second pointer, j, watch at second element initially. If they're the same, yes, then we just continue to the next iteration. Now we watch to the third item, third element. It's not the same, then we put this item to the second place after I. Then we assign. We should not I should not assign it to the j, because I need to assign it to I plus 1. Yes. And j should be and that's it. Let's try. Whoa. And I don't. K equals I. I plus 1. I skipped something. Oh my god. I need to debug it. Well, so the first one works well. Our I look watch. I is the first item, J is the second item. We continue, then J is the third item. What we do, we increase I, then put the item from J place to the third place to the second place. I watch at, now I is the second item, J is the third item. J is the third item. We don't need to break it. Maybe. I don't need to break it. It works. Why the K is wrong, has wrong length. We need to assign K outside of the inner loop. Let's try this approach. So we have unique items and I need to break it somewhere, but when? I need to break it when? Come on guys, why you check the rest of the array? Okay, we got here, we on the first, on the fifth place. So I watch at the it will be no, sorry, we put 3 here and our J watch at this 3. We moved it on the 4th place. Yes. Then we increased the I. No. The I watched here, we increased the I. Now we watch to 3. Here is the 3. J here. And we continue to iterate. On the next iteration, j will watch at the second 3, it will be equal, we continue. We continue. We continue. We continue, and j will go to the last item. Last item, it is the last item is not equal, so we put it to the next after I, then we increase the I, and we put 4, the last item, to the 5th place. Then we can make this check. If j equals nums length minus 1, then we make k equals I plus 1 and break the loop. Also, I need to, every time when I start over, we break the inner loop, but the outer loop continues to working. How can I break the outer loop? If the current item equals to the last item. If nums I equals nums length minus first place item, then we make the same thing, I plus 1 and break. I think I don't need in the inner loop. Yeah, I can submit it now. Oh, I beat 39%. I think it's because I make some unnecessary iterations in the inner loop. Every time in the inner loop I iterate again, iterate the j not starting from the current position but starting from I plus 1 position. But I don't need it. I can continue. I need to continue from the current position. So j shouldn't be I plus 1 every time. Var j equals I plus 1 for the first time. Var I equals 0, j and I need to change it to while loop. While I need to increase I inside the loop every time until the or and nums I not equal to the last item. I don't need breaks. For the inner loop, I also need to change it to the while loop. While I increase the if and I need to put it here, then I don't need continue, and I just increase the J every time, something like that, and nums length will be I even don't need the K additional variable. Let's try this solution. Oh my god, I is not defined, it's just syntax error. I can I plus 1 I need to increase the I here one more time. I think it's okay. And in the end, the nums length will be just I. No. Why I don't. Because of I use the while, I need to make it. I need to work with this in another way. So nums length minus 1. Maybe this one will work. No. It go to the end. Why it go until the end? Let's try to find it out. First iteration, we look for the first item, ij on the second item. They are the same, and we just increase the j. Okay. On the second iteration, I doesn't equal j, and nums I doesn't equal j. So we increase the I, put here on the increased I the nums j, 1 will be put here, and we go then we increase the I one more time. No, we increased it, and then we go we don't need to increase I here, I guess, because we increase it here, and that's it. And plus 1. Yes, let's try to submit it. Whoa, we beat 80% of users with JavaScript. Nice, I like it. Why I use so much memory, I don't know. I don't have a lot of new variables, only these two. I have two nest. Maybe I can use only one loop. I don't need nested loops. I can try to use only one loop. Yes, I can write it here. Then I can remove this nested loop. Let's try it. Yeah, it's accepted. Let's watch. Is it helpful? Yes. We good, guys. So we got nice solution. I find out the method of two pointers technique. It works for sorted arrays, and it lets us to iterate the collection only one time. So it's good for performance. I like it. Let's watch other solutions on JavaScript. I think it will be same. Intuition. First we check vectors. Let's go to the solution. If nums empty, return 0. Just guard solution. I less than. Why he started from the first item, not from the second item, not from the first item. Nums I doesn't equal nums I. Aha. Sorry, man. Don't call me. So here, compare it with the previous item. Aha. If they're not equal, he put the current item to the k, and even then, only then he increase the k. Let's watch the comment section. Thank you. Overwriting, by the way. Does one come up with such ideas? Yes. Yeah, it's smart solution. It is improving of the classic solution. I can tell it like that. Nice. It's the next level. It is the next level. I like it. I want to vote his solution. How can I vote it? Do upvote if you like the solution explanation. How can I upvote the here we have the button. I upvoted it. My easy JavaScript solution. Nice with this one, but I don't like this one. I understand that it will be the I when we will assign the 8th item, and after this I will be increased, as I understand. One more hacky solution, but I like it. I see it, yes. I thought backward, but now I understand it, yes. It 2 pluses means that it increases the value, then the nums will watch to the increased value. If we will write pluses after I, then nums I will be the current value, not increased, and it would watch to the previous I, and after this assignment only, the I would would be increased. Okay, I'm done for today. Thank you. Bye everyone.